Hello everyone and welcome to the introductory video for Auggie. It's being released in alpha this month. This is December 2015 and we're looking for anybody who would like to play with Auggie and happens to have a Pokies. Auggie is a free controller, so anybody with a Pokies can jump in. It's just another tool to have in your arsenal, and let's take a look at the things you can do with it. First of all, we should talk about the hardware that Auggie uses as its standard hardware. It can talk to the Pokies 57 CNC, which is an 8-axis 125 kilohertz controller. It can talk to the 57 and 56 E's and U's, which are USB and Ethernet controllers. These all come with a 3-axis 25 kilohertz controller on them. The Pokies 57 is the one that I'll be using for converting Auggie into a laser controller over the next few months, but I have tested it with the 57s all the way back to a 56 U and the 57U, and they all work fine. There are 3 reasons why I chose the Pokies for those that have asked. Number 1 is facing you on the screen here. This is the Pokies Configurator. It's the same for all the Pokies devices, and it allows you to configure a Pokies. Here's my 57 CNC with 8 axes. I can set everything from acceleration to deceleration to the homing speed to soft limits, and I can test my motor positions all from within here and then save the information, and Auggie will use it directly out of the device. So I don't have to write any of this configuration. It's all built in there, and Pokies will do it for me. That's the largest reason that a Pokies was selected, other than the fact it's a incredibly versatile device. Anyway, that is the number 1 reason why a Pokies selected. There are 2 more important reasons. And the second reason is this. I can open up a web page, hit a status, and now I can, in real time and from any computer, view the changes that the controller is making on the device remotely. This really speeds up diagnosis of a problem. And here would be the third and final reason why the Pokies came to the top of the charts. All the other devices are all very good, the ESS, the PMDX, and so on. But this was the only device which allowed me to have an open source C++ library that allows me to hook to any portion of the device. So that in the end, the Pokies gives us a whole lot of functionality. Alright, Auggie is started with the new red icon on your desktop, and you'll be asked to create a profile. I already have one, so I'll just select what I have. And starting Auggie is as simple as that. You will hear some sounds on starting up if you have audio selected. I tend to keep audio selected because I like the clues that it gives me. For example, when you do something that you're not allowed yet to do, you'll hear a sound like that. And that's because I haven't enabled jog. You may hear that stepper motor going in the background, and I'll warn you that the video recording software can cause glitches on my system. So you may hear it glitch at some point. Also, I have my rapids set a little high from testing. Okay, let's take a look at some of the features of Auggie so you get an idea of what you're looking at. Okay, configuration in Auggie is very simple. Run the Pokies configuration software. I will show you that on the next video on configuring your Pokies. But generally, Auggie uses what's in the Pokies for its configuration. There are only a couple of differences to that. First of all, on the Connect button on the configuration, we can select which Pokies we're going to use. We can use 2 at once, one for motion and one for I/O. Both of them, of course, can be used for I/O. We also have a menu item for saving or restoring the config of a Pokies. This will read the Pokies and save it as a file. And this is so that I can rapidly switch between Mach 3 and Mach 4 and Auggie by reprogramming my Pokies from a saved file of the configuration they have for whatever program I'm using it for. We have a rescan button so that you can see which Pokies are on your network. This will scan and use Pokies both on the USB side and on the Ethernet side. The rest of the configuration is really, there's an engine configuration button here, which allows us to set the acceleration and velocity on each of the axes, and the steps per unit. You can also select whether or not your soft limits are on and what is the boundaries of your soft limits. Soft limits in Auggie will automatically slow down the jogging and so on as you approach them. My soft limits, for example, are set at 500 millimeters, and you can see that as I get to 500 millimeters, my axis automatically slows down. If we look at that in a motor statistics look, we can see I'm shooting towards my goal, and my axis just slows down exponentially as I approach it. The program, I'll jog away from it and jog back to it. The program is designed to keep it always 2 seconds away from soft limits, so it slows you down automatically to be sure that you can't get there. The motor stats button, incidentally, is a very handy way of seeing what your system is doing. The blue is jerk. It is actually mechanical energy being given to your tool. There are various color lines for the velocity of each of the axes, and a black line for the overall tool velocity. If I say go to 0, you can see we get an overall tool velocity, and we race off. Now here my video software is interfering with my speeds, so we begin to lose a little bit, but here you can see the acceleration and deceleration waveforms to get us to move around, and this can come in handy when you're tuning your motors. And that's the motor stats screen. We also have a real-time multi-threaded debugging scripter and librarian so that you can write scripts to control the system. The screen is shrinkable, and whenever you bring out something that you want to look at secondarily, the system will shrink down. There is like a diagnostic screen here, for example, and as you can see, the whole screen shrinks down when this is open. This is still a fully operative screen, however, and all the indicators work and files will load and so on. You can send that back and zoom it away. And that's pretty much all the configuration is to Auggie. It's pretty easy to deal with so far. We've tried to multiplex a lot of the items on the screen here, and above the screen you'll see 4 of the most important ones that you'll use: G-code, single-line MDI, multi-line MDI, and script. Auggie is an inventor's toolkit, so we have several areas on the screen where you can keep track of what you're up to. These last 3 tabs, single, multi-line, and script MDIs, are all persistent. Every day when you come on, the same files will be in them. If you're in a multi-line MDI and you hit run, the entire file will run, whatever is in this screen, from the line you have selected to the end of the file. It will then stop and rewind. But you can start in the middle by clicking on a line to set the execution line, or you can enter a line in the execution line to go to that line, of course. Single line MDI operates one line at a time and then moves the cursor down to the next line. And you can, if you press run sequentially, stack up lines. Then we have our G-code window, and this window is where the G-code will show up when you load, and up here inside the large A, which is our file menu, you'll see you have open, edit, close, MDI multi to G-code, G-code to multi. Let me explain the last 2 first. MDI multi to G-code is because as an experimenter, you may be in here typing code and testing it on the screen to see what it looks like, but your extents and things like subroutines won't work in an MDI environment. So you may occasionally want to send that to your G-code. So you can hit the red A and say MDI to G-code. And when you do that, if we look at our G-code window now, you can see it's a copy of our MDI, and it's been pre-processed. The G-code files are read 3 times in order to garner a lot of information from them. And once you send your multi-line MDI there, now the extents on the screen actually display what the size of that file is. So if we were to run it, now the screen contains what you're running, and you'll be able to see the toolpath of it. These 3 screens are actually kind of interrelated, because you can, in a multi-line MDI, put your single-line scripts. You could even copy and paste them across if you liked. The script line is only for scripts, and is for typing quick C scripts that you want to execute that may control the screen, or it may modify the toolpath that's in operation. Multi-line MDI can contain scripts as well mixed in with its G-code, but it will follow the same rules as the G-code screen does. Let's take a look at a subroutine file for an example. Here's a subroutine file that I was using as a test, and here's one of the reasons that you're still going to want to have Mach 3 or Mach 4, because I've thrown away the RS-274G standard. I didn't care for a lot of things in it, and as an experimenter's toolkit, this really didn't need to follow that standard to that level. This is not a standard CNC program, and I suspect a lot of us don't like dealing with some of the esoterics of G-code anyway. To try to figure out what a G10L2P1 is doing compared to doing something as simple as saying engine call subroutine circle twice, which almost anybody could read for this particular line. Engine words in Auggie mean that you're sending a command to an engine, and in this case we're saying call subroutine circle and call it twice, and yet the rest of the lines are G-code. Only thing that varies are the declarations, like this is a subroutine called triangle, and then down here we have another script, brace, engine return. Anything in braces is a script. So if we were to run this, you can see the constant velocity taking over as it rounds the corners. It jumped down into the circle subroutine. It will run it twice because of our command up here, and then continue on its way. You can nest up to 200 levels deep within subroutines because subroutines can actually call subroutines. Here I'm getting a message from my top tester telling me that the feed rate is not getting updated, so I have another bug, and that's something to be noted. We got lots of bugs in here. It's going to take a community of people testing this and a period of time for us to remove the bugs. Okay, I'm going to quickly mention, let's take a look at our screen. You can see the effects of constant velocity as it comes out of one sweep and into another. And I have the constant velocity set enormous at the moment at 35 millimeters. If I was to lower this down to, say, 15 millimeters, which is still large, I'm going to hit rewind and run this again. And you can see that the circles are getting smaller on the corners. They're not always intuitive as to the size that you're going to get, and the reason for that is because they depend on the speed that the planner has seen it coming into a link with and coming out with. It's quite a complex motion planner, and it's sometimes hard to tell exactly what it's going to do with a given constant velocity bend. Alright, so let's take one more quick look at file loading, and let's load a file with an error. You can see that the zoom or the scroll bar doubles as a progress bar for the loading of a file, and you'll see there's a lot of marks in it. Statistics are gathered on a file, and the scroll bar is actually used as a zooming magnifying glass into the file. You can see, for example, here there's a red line, and that means an error. So if I go to that error, you'll see that it doesn't look like an error, and yet it's showing up as an error. If we hold the mouse over it, we'll get a message telling us why, and it says parse error, variables not allowed. Auggie does not allow pound variables. I've always hated the buggers and decided to remove them from the spec. So we're not going to have pound variables. So you would have to fix that before you could run this particular file. Now let's load 1 millimeter spiral so that we can talk about some of the runtime capabilities of Auggie, and probably what will be one of the most enjoyable features of it, which is the continue processor. Alright, so here I have a spiral on the screen which I wrote long ago to run a photograph on a laser, and we'll use this as a test file. I'm going to rewind it and hit run. Now, one of the things that I started this with a feed rate of 15, so it's going very slowly, but it's good enough for us to illustrate a point. Actually, no, it isn't. I want to go faster. Okay, I've restarted this with a feed rate of 3,000, and let's start the file going. Now, I'm going to hit stop here. You can see on the screen a light turquoise. That is the actual motor position coming back from the Pokies. We're sampling it at up to 100 times a second, so you get a very small deviation between the two. So unlike Mach 3, you don't get straight lines on something like a spiral as it builds. The white lines are the result of me stopping the file, and whatever line I'm on in the display will light up white on the screen. So the white lines light up on the screen as I move my cursor around. So that's what's on the screen at the moment. You'll notice though that since I stopped, this continue light is blinking. This is the continue processor, and its job is to make sure that you can always restart a job, whether you're shutting down for the night or you're anticipating a power outage, and you could even script this to happen if your UPS said power was going down. To show you how powerful it is, you'll see that I've just stopped. Let's just hit continue, and you'll see our spiral continues. Let's stop again. Now let's jog away. And let's make it even more challenging. Let's switch to the multi-line display, and you can see here I'm cutting a 100 wide square. So let's run that. So you can see we're cutting 100 on a side, and we went back to 0. And let's make it even more complex. Let's kill the program. All right, the program's dead. We're going to bring up Auggie again. And the continuation processor always makes sure that you're covered. You can see it's still blinking. And this means that whatever job you shut down, and however you shut it down, as long as you stopped it to create the continue point, you can hit continue. And if I hit continue, you can see G-code just loaded. We got a sound that indicates to me I should look at this screen for a message, and it says file loaded, press continue to continue. And if I hit the continue button, we'll get messages about where we're going. We can set the final feed rate on the last position. We're shown that as line 58 that we stopped it on, and we can just hit the move and continue button, and the program will go back to doing the spirals it was doing when we stopped it. Now you may hear my stepper motor jerking around back there, and it's because it doesn't like Camtasia running at the same time. But away we go, and we continue. And you can stop any time, and as long as the light is blinking, it's going to continue. It won't ask you anything if you stop from that spot, but if you jog away or anything, and then hit continue, it will ask you how to go back, and then we'll move back. I haven't seen it mess up yet. It's extremely reliable, and should be an extremely popular feature, I would think, because I can't count the number of people who have asked me over the years, how can I shut down for a power failure, or how can I let my employees go home at 5? This could stop the most complex of engravings on a dime, and then pick it up tomorrow. And you, like I said, you can just kill the software now. When you have a continue point going, there are a few things you can't do. Like you can't zero the axes. It will warn you to delete if you intend to do that. Same thing with a rewind. But you can run other code. You can't load another file, but you can load other code. You can run scripts and do things which may be auxiliary to what you're attempting to test. So as you can see, Auggie is really an experimenter's platform. It's meant for playing around with things like lasers and the type of things that we deal with over here. I hope that a bunch of people will join in and try it. If you have a Pokies, you got nothing to lose to give it a shot. Auggie's a free program, doesn't cost anything to run it, and hopefully we can all have some fun with it. I'm going to have to make several videos, of course, to explain things like the multi-threaded script debugger, the librarian, where you can pull out scripts which run things during the runtime. You can modify quite a bit with Auggie, and the scripting in Auggie is very simple. It's easy to read, it's self-typing, multi-threaded, and even preemptive. So that's an introduction to Auggie. I hope that you are in a position where you have a Pokies and can play with it, and I hope you enjoy it. Merry Christmas 2015. Alright, one more section of Auggie we should talk about is the screen designer, because Auggie actually started life as a screen designer. It then had scripting wrapped around the screen designer, and then had a 9-axis jerk limited planner thrown into that mix. So the three of them share importance in the system. And here in the configuration, I just have a checkbox for edit mode. And if I go there, I'm now in an edit mode. You can grab and drag controls. You can click the control key to select multiple controls, right click and align them. You can click on a control and set its properties to change its shapes and to change the way it works and to enter variable names. There's a great many things that you can do with these. There are only 3 or 4 types of controls really. This DRO for the X is actually identical to this elapsed job time and this clock. It's just different settings within its properties. We'll have to make a separate video to show how these things all come together, but suffice it to say that as a screen designer, Auggie excels over what I had to force people to do in Mach 3 with Screen 4. Anyway, we'll talk about this more in a separate video. I just wanted to touch on it so that you can see how Auggie does have a screen designer built within it. And within that screen designer, you have things like these diagnostic panels. A diagnostic panel is really just a screen that you've saved and said you want to use in a screen. So they then become zoomable screens within the screen that you've designed. Anyway, that's enough said about screens for now. I just thought I'd touch on it during this introductory video.